Hi there, and welcome to the wonderful world of cryptography. So, what is cryptography? What are we going to be talking about today? We're talking about hashing, and we're talking about encrypting and decrypting using a variety of algorithms, and there are a variety of them out there. I'm going to cover some. Obviously, I can't cover them all, but this will be a great introduction, possibly to the subject matter, and also possibly to one way of approaching this. So today's video is broken down into two concepts. We have hashing, which is going to take a string that you pass to it through some algorithm, and it will output a resulting hashed string. So it's going to be another representation of that string, but there's no way of backwards engineering what it outputs. So it gives you some randomized string, or at least it looks randomized to you. You cannot then take that, put it through some other algorithm to get back the original string. It's a one-way hash. But it's a verifiable hash. So if you run the same string through the same algorithm again with the same parameters, you'll get the exact same hash. So although you're not aware what the initial string was, you can validate that whatever was entered previously does match up with what's being entered now. One thing that I've actually used hashing for is I've used it to identify duplicate files in a computer, because a file hash is unique. So even if the file names change, the file hash itself for the binary file will remain constant. So I basically created a database, and it went through my system creating hashes for all the files, and then it was a simple thing of running a query and counting the number of occurrence. Anything that was more than one, I have duplicate files. So hashing can be a great technique for all sorts of things, not just analyzing information. Okay, getting back to subject matter. So we've talked very briefly about hashing. I've given you a very summary idea of what it is. The second element of cryptography is what they call ciphers, ciphering. And that's encrypting a value with a key and whatnot, a passphrase, and then being able to decrypt it at the other end to get the exact same string that was inputted. So this, with ciphers, it's reversible. What you use them for is somewhat up to you. A lot of things like passwords, they don't want ciphering anymore. Okay, we want to use a unique hash, but no one should ever be able to extract what that original password was. We should be able to validate it against what was stored, and the hash will permit us to do that. But using an encryption decryption is probably ill advised, because if someone malicious manages to get a hold of your system and decrypt, then they'd have access to all the, let's say, passwords. In a database environment, if we're getting back to something like Excel, Access, things like that, hashing has less value. Okay, typically we're going to be looking at wanting to do ciphering, encrypting it, protecting it in the tables, and then having a mechanism in our form or whatever to decrypt it to show it as plain text to our users. But knowing that if anyone ran off with the backend, it would all be protected. These techniques are also important, especially ciphering, if we're connecting with remote databases. I use certain web databases where I have completely encrypted the data. So whatever is entered through forms by my users, it gets encrypted on the database. In my case, MySQL or Azure. Well, using Cipher, I am there able to connect with my Access frontend, and I'm able to decipher, decrypt those fields, those columns, and extract the data as it should be. So, it isn't necessarily just for a plain access situation here. This extends far beyond encryption, decryption, hashing, all that goes way, way beyond all of that. So today we're going to look at these two elements. Now, I have an article that I've been working on. Actually, by working on it, I perfected the code significantly. Originally, I was just going to do a simple one or two example thing. When I got into it, I couldn't help myself but just keep pushing and pushing and pushing. And then with testing, I managed to find a couple bugs, and then I extended the functions, and you know how it goes. But just to mention right off the bat, I had previously done some articles about getting hashes. Here I'm talking about string hashes. I also had done articles about file hashes. If you just take a very quick glance at it here, as you can see, I'm using PowerShell. So it is possible to use PowerShell to do some of this. Not all of it, but some of it. So no, that is always an option. But whenever you're pushing out to PowerShell, there's a performance hit. And I wanted to see, and I also wanted to explore, what other options we had available to us. So this is where I once again turn to web development, because that's where I've been spending a lot of my time. And the simple fact of the matter is, nowadays, a lot of this is built straight into browsers. We don't even need external libraries. So I had to go digging a little bit. And I found an older JavaScript library that existed. And it's actually quite nice. And it permits us, as I indicate here, to do all these different types of hashing. And I'm sure most people are very familiar with MD5, for instance. And if we're talking about ciphers, so encryption, decryption, we're able to utilize these guys. Now, if you come here and you look, I've included multiple versions of the code. It's more of an educational thing. If ever you wanted to see a little bit how I start off here, as you can see, I created an individual function for each hash, for each cipher. And then for each cipher, actually, you have to create two, because you need to create one for encryption and one for decryption. And then, like I said, as I was working on this, then I evolved it, and I managed to create a single function for doing all hashes, where now I pass the hash algorithm to be used. So I'm able to reduce needing all these different functions to just having one function that does them all, but now I have an enum that gives me the option to select which one I want to use. And because I had mentioned later in the article, self-healing object variables really beneficial in this type of situation where we're calling this type of function over and over. So I just wanted to illustrate how easy that was to implement. Now, yesterday, while I was preparing to try to make this video, I discovered a couple bugs, and I also wanted to extend the functionality a little bit. So I came out with version 2. You're going to see the change from version 0 to version 1 is quite massive. But the change from 1 to 2 is pretty minor. Nonetheless, like I said, I did remedy a noticeable bug. So at the end of the day, it's here. The other versions are here. If you want to really take a look and see how things can evolve, and especially jumping from version 0 to version 1. But at the end of the day, this is the guy you're going to want, or in reality, the best one is using self-healing object variables. So if we just quickly go through this, you're going to see we have basically, right at the top, we've got our self-healing object variable declaration. We've got a crypt hash self-healing object variable function. And then we've got, if we keep going down, eventually we'll get there, come on, a crypto cipher self-healing object variable function. And that's it. And that permits us to do everything we're going to look at and explore today. Warning. Now, I'm using a library which is called Crypto.js. And it's a very good, in general, library. However, doing these tests yesterday, I discovered a problem with using the SHA-3 version of hashing. And after looking into it, because I wasn't managing to ever get the same hash when I try to validate it with various online sources. And I eventually found someone had posted this blurb indicating that this version of SHA-3 was based off of the initial specs, which were going to match up with a certain variety. And then at the very last minute, for whatever reasons, they changed the specs. and he didn't update his library. So he's in line with Ethereum and Kikak, but not the latest implementation of SHA-3. All of this to say, if you really are dependent on SHA-3 hashing, this is not going to be the solution for you. Do note, however, I did a very quick look. There are other JavaScript libraries that you can easily implement in the same manner I've done with this. But nevertheless, this library still provides a lot of power under the hood for doing all sorts of other hashing in Cipher. So let's keep moving on. Just knowing in the back of our minds, SHA-3 is probably not a good use here. Like I say, validation. I've done some, so I'm confident in what I'm showing you today. However, if you want to do extra validation, which is always a good idea, especially before going into production, there are tons of websites out there that offer all sorts of hashing or ciphering encoding. These are two of them, and like I say here, this one in particularly I really like. If we just very quickly come take a look, if you come here and just type in whatever string you're trying to encode, and you do it, you can come down and all of them are offered here to you. So you can see in one glance whatever it is you're looking for. I know I'm on the MD5 page right now, but it shows you every version of every hash possible. So if you need it, this is just a great one-shot deal and you've got your answer. The one thing I will mention at the same time, however, doing this validation yesterday and doing tests on various sites, be careful, not all sites are created equal. I found multiple sites that were giving erroneous hashes. And as such, then it made me second guess myself until I did much more validation. I was able to prove that no, what I had was correct and that it was the website that was incorrect. So anyway, just keep that in mind, but you do validate what you're doing before you put things into production. Considerations, as you're going to see here, I offer two options for the JavaScript. You can have a local copy on your computer, which is the preferred route, or you can also use a CDN version, so off the internet. Obviously, the local version is going to be faster. There's a delay connecting anything to the internet, and I had to therefore implement a sleep in many instances just to take a little delay to give the function a chance to download that file and process it. Not a huge delay, but still we're adding a delay to the function call every single time. Whereas using the local file, that was never required. So then, like I say here, I need the sleep. So if you need to grab a copy of that function, you can do so. I have the link here. You just come here, the sleep API, and you just copy this, copy paste it into a standard module. Like I mentioned, self-healing object variables. You can read the detailed article. I've mentioned it many, many times before. And you'll see here that you'll have all of the different declarations and gives you an idea of how all of this works. So come here, you can understand the basic principles, but I've already provided above a complete functional version of the code that you'd be required to use. So dissect it and enjoy it. I've already done the work for you. Then I provide a couple links here. This was the original library, and it was basically stopped or no longer updated as of version 3.132, something like that, by the original author. And then later, this person here, took over. And if we come down to the bottom, we're now at version 4.2.0, and that's the same version that you'll find on the CDN, and that's the one that I copied onto my local machine. So just to give you an idea of what is available, and if you go on the CDN and you don't want the version 4.2, you want some earlier version, they're there for you as well. You just have to change what you're taking. So if you come here on the CDN and you take a look, crypto libraries, it always loads the latest. But if you come here in the version, you can pick any version you want to take. Okay. So, but what I did is I simply came to 4.2, and this is the guy here that I'm really interested in, and I just copy pasted this into my browser. This is the file. You do a simple file save as, save it as, and I save it with this file name here. It's a JS file, but in reality, you can open it with any text browser. And I placed it into a folder on my computer that then I reference in my functions. And we'll look at that next. But just know that all the code, the JS library, whatever you need, it's all available here. So let's dive in. Let's take a look at how all this works. So let's start up our database. And we go into crypto. So as you can see, I've organized myself here. A couple modules, they're organized by version. Really straightforward. We're going to dive straight into version 2, and I guess we'll go straight for the self-healing object variables. The two versions are extremely similar. Actually, I should mention. So all my enums I have in my version 2, but they're accessible right through my other modules. But I created a series of enums. So these will be used in all of my function arguments. That way people don't have to type specific things. They just make a selection from a list. It simplifies calling the function greatly. So I have what type of JS library are we using? Is it a local file or are we using the CDN file? Which, if we're doing hashing, if we're talking about hashing, which hashing algorithm are we using? So they're all here and they all correspond to a number that I'm able to utilize in my function to apply the proper code. Same for ciphers. Which cipher am I going to use? So I've got these options here. In the case of cipher, which direction are we ciphering? What does that mean? Are we encrypting or are we decrypting? That's as simple as that. And recently, well, as of last night, I also now provide an option as to what format do you want to output in. So by default, I'm outputting, well, it depends. It depends on the cipher if we're encrypting or decrypting, but we're going to be either UTF-8 or hex. But if for some reason you want it in base 64, well, you can do that. You want it in Latin, you can do that as well. The options are there. It's configured so you don't need to worry about the output format specifically, but do know you have that capability. So then we have the functions, the two functions. How does it work? Well, if we just take a very cursory look at this, it takes 4 input arguments. So the string, the text, the hash, which algorithm to use for the hash, which type of JavaScript library we're using, the local, the CDN, and then the format. So here I'm defaulting hashing format to be output as hex. That is typically what you're going to see used, but you can always override it. Here we have early binding and late binding, depending on what you've chosen to use, and a couple declarations. I empty my HTML files and there's no content to begin with. Then I create a paragraph tag with an ID of result where I'm going to push the output of my JavaScript function, my hashing function, and I will recuperate the value from this paragraph tag later. Now, depending on the location of the JavaScript, if it's a local file or if it's a CDN, we have to create the script tag differently. So, in the case of a local file, what I've done is I've placed it in the same folder as my database, but then I've created a folder JavaScript, I've created a subfolder for that Crypto.js, a subfolder for that 4.000, and that's where I placed my JS file. Obviously, you want to make that correspond if you're going to this level, that it matches up with the version that you've actually implemented. So if you're using 3.12, make sure that's reflected, not to induce any future developers in error. You could have just as easily have put it directly in the same folder as the database. This is entirely up to you. You organize your structure as you see fit. Just know that we declare here the path of where that file will be located. Then I create a script element. I set the src, the source attribute, equal to our path that we just declared here. Where is that file found? And don't forget, we want the prefix at the beginning here of file : and then triple front slashes, forward slashes. Then we append that to our HTML file. So that's for the local copy. If we're using the CDN file, the code is actually there if you take a look, but here it is implemented through VBA code to create the exact thing that they present to you on their website. But we're going to create the script tag. We're going to then set the source to the CDN that is available there on their website. So I didn't invent this, but it's pretty simple syntax at the same time. They also demonstrate using integrity, cross-origin, reference policy. So I just copied exactly what they showed, and then we append that to our HTML file instead. So now we've got our library available to us to use. Next, I'm going to do a couple select statements to get ready for building the command, the JavaScript function that will do the hashing. So how do I do that? Well, first I'm going to take a look at what hashing algorithm was selected by the user. And then based on what they've selected, I then set the string variable for the hash. And in the case of SHA-3, because the syntax is different, I've also added here a Boolean SHA-3 equals true just for those 4 instances. In all other cases, it would be false. Same for the output. I come here and I just simply set up what was selected as the output, the desired output format, and then I create a string that represents that I can then use in the function that I'm going to build. This is where that Boolean comes in. So here I'm going if not a SHA-3, so every other case, we're going to have this syntax. In the exceptional case of SHA-3, this is the case. Now note, as I said, SHA-3 I'm not recommending anyone use. So this case here is almost worthless. Well, unless you're doing Ethereum and things like that, it's not much value. But we're going to now come here and we're going to execute a script. What script are we going to execute? Well, we're going to execute this crypto script here. And we're going to push whatever it returns back into our paragraph that we built at the top, which was entitled result. So what is the command? Well, it's very simple. Crypto.js dot, then the hashing algorithm. So whatever we've put here. So then we come next is the string that we want hashed. And then here we're going to output it as the format desired. And by default, it would be hex. But if you wanted it to be Latin, it can be Latin, base 64. It can be, you can't really output it as a UTF-8, however, because we're typically providing UTF-8, because we're providing a string. So just note that if you try that in many instances, it will generate an error. The case of SHA-3 is they have a different way of handling. We have to also include here the output length, and that's where I go and I pull off the last 3 characters. So let's see right here that I will put here to designate the output length. So that's why it's a very different case scenario. There's a different syntax to the actual crypto command. So once that's done, this runs. Now my paragraph with the paragraph tags with the ID of result will have the output of that function. We will now have a result. We will have a hash string in that paragraph tag. So the last thing we do is we come and we tell it, go find that paragraph tag by that ID and retrieve whatever's in its inner text, because that's my hash. That's what I'm after. And return it to my function. So it's really very simple. And if we just come up very quickly, I have an example. We'll just copy paste it. So we're going to crypto hash. This is a test, and I want the output as an MD5. If we do that, we get this as our hash. If we wanted, it's not very hard. We can switch. What do we want? I want it as a SHA-2 512. And I'm going to use the CDN version, not the local, because by default it's local. And we'll do that. And there you go. No, I've changed my mind. I want it local, but I want to bring it and output it as a base 64. There you go, base 64. I want it as Latin 1. There you go. So as you can see, it's very versatile. It's very easy to use, and there's a lot of flexibility there. So you can now hash very easily. Next is ciphering. So ciphering, I have more arguments, yes. So we have the string we want to, I put hash, it should be cipher. Now we need to also include a passphrase. So this is our secret. So if the person doesn't have the secret at the other end, there's no way for them to decipher it, decrypt it. Then we have to tell it which cipher algorithm to use, which direction. So are we encrypting or decrypting? Once again, the JS file location, is it local or is it the CDN? And what output format do we want? You'll notice here I'm not defaulting the output format because the default that I want will vary on the direction. So I'm going to show you, we cover that a little bit lower. But basic same concept, early binding, late binding, some declarations. We clear out our HTML file. We create that result paragraph tags. We build our script call depending on the file location for our library. And then here I'm doing very similar to above. I've got select case statements here to transfer basically the numeric values into textual values. That's all I'm doing. So I can then have textual values for building the necessary command, JavaScript function command. So I do that for the cipher algorithm. I do that for the direction. Now, this is where I also, not only do I get the textual representation of the direction, but now I'm checking if no output format had been specified when it was called, the function was originally called. Now I'm defaulting for encryption that the output format will be hex. And for decryption, the output format should be UTF-8. Now, obviously, you can override this. So if you specify something else, this won't actually override it. It will keep whatever you've chosen. Then we do the same for the output format. And then we come down here and we're going to build our commands. Now, why do I have two? Once again, simply because of the direction. So if we're encrypting, we're doing this. If we're decrypting, we're doing that. That's all. You come through, it's the same idea. We're going to pass the result back to our paragraph, result ID paragraph tags, same thing here. And we run this command. What is the command? Well, it's crypto.js, whatever the algorithm we've chosen, the direction we've chosen, then we give the text we want ciphered. We also have to pass it that secret, that passphrase, and output it to string. Next, we come and we look at the decryption, and it's very similar, except that you've got your algorithm, now your direction, your text to hash, your passphrase, and here we're going to string, but here we're going to allow different output formats. So this is where whatever you've selected will come. Now by default, I'm going to be setting UTF-8, but you can override that. Once again, the last thing in this entire thing is to then go read what was passed here to the result. So we're going to read that and push it back to our function. What does this result in? It results in being able to do something like the following. So I'm going to come here, I'm going to cipher this phrase, this sentence. This is my secret. Now your secret can be whatever you want. You create your secret, your passphrase, and you have to protect it because that is what is basically your locking mechanism. If everyone has access to it, well then they'll be able to decrypt your information. So this is very important that it isn't out in the wild for everyone to have access to. Then we specify the algorithm we're going to use, and we specify which direction. So we'll do this, and we get that as an answer. Now notice when we encrypt, the values change. It's the same string being ciphered, it's the same passphrase, the same algorithm, and yet we get multiple values. This is normal in the encryption with ciphers. Now, if we come here, and let's just simplify this onto one line for right now, and we take this guy, and we put it here. So we're going to decrypt this using the same passphrase. It has to be the same passphrase or it won't decrypt it properly. We have to use the same, obviously, algorithm, except now we're doing decrypt. This is a test. But equally, we could have taken the first one or the second, doesn't make a difference. It will always result in the same text because you've just ciphered it, okay? So just note that it's normal that if you run the same command that you get different values. The decryption will still result equally. There will be no issue at that level. You can obviously come and you have all these options, obviously. You can use the remote one if you want. You can say I want it in a base 64. Well, there's your base 64 representation of this as a text. And if you go on different websites, you can confirm that that is truthfully the proper representation. So you have these abilities now to encrypt, decrypt, and hash. Very quickly, how do we then take this now and make it into a self-healing object variable? Why am I concerned about it? Well, the concern here is that every time you call this function, or the hashing one, you're always executing a create object. Now, create object, any create object, is always going to be a slower, quote unquote, so you're taking a performance hit. So what's much better is if we can do this the first time, yes, there's no way around that, but then keep it in memory and just keep using it over and over, so then we don't have to keep doing this call. So that's where self-healing object variables come in. If we look at it very quickly, I'm now declaring module level object variables, okay, depending if you're early binding or late binding. Then we're going to create this function that now represents that file. Remember, the OHTML file. Well, now I'm going to represent it here at a function level. So it's going to automatically get called and fired. And it's going to come and it's going to check to see, does this already exist? This object, has it already been created? If it has been created, it does nothing. It just skips over all of this and just pushes it back out. So it doesn't need to do that process of initialization. But if it doesn't exist, then it will come here, and depending on early and late binding, it will create that object for us and then pass it. So basically, the first time it runs, it will have to go through this. But subsequent calls, it will skip over this entirely, and it just performs this set for us. So it's much faster. The more you call it, the greater the benefit. And then we just remove here in our code anything that has to do with the OHTML. So we don't have the declarations, we don't have the set, remember here? So we're not having the dim, and we're not doing the set, and we're also not, very important, at the end of it, come on, we're not clearing it either, there's no need to. So we're going to come here now, and there's no indication anywhere of that variable. But it will work just fine because it's actually going to run that function and get the value every single time. So what we can do, because I named them identically, except I added show, we can run the exact same thing. Now, the first time, as you see, it says setting OHTML file. But if I run it again, it doesn't have to do that setting ever again. And that's where the performance gain comes in. And if we come here and we do the show here, and we can remove this to bring it back properly to UTF-8, it works just fine. And we can take any one of the ciphers that were generated using self-healing object variables, they will work just the same as well. Similarly, like I said, you can do the hashing, and we can come here and pick whatever we want, and there you go. So that's the benefit of self-healing object variables. is it's a performance thing. You're going to gain on the performance side. In considering typically hashing and ciphering is something you do extensively, right? Every time you're going to save, every time you open a record, you want to decipher, decrypt. So you're going to be running this a lot. It's beneficial to use self-healing object variables. If this was something you just ran once, then it's no big deal. But the more you use it, the greater the benefit. And that, my friends, is a summary very quickly of doing cryptography through VBA using the Crypto.js library, which is available to us to use. And as you can see, it's phenomenally fast. There's no issue here. Obviously, the longer you get into writing text, it may take longer to generate certain hashes in ciphers, but it doesn't make a difference. It's still bloody fast. So just giving you an option here. If data security is important to you and you want to encrypt, decrypt, or hash, maybe even just as simply as hash your user passwords, so if anyone ever manages to get into your system somehow, they still wouldn't be able to read them, which is a great security measure. And this is what any normal website does today, for instance, but you can now implement that easily within your own database or any other tool, Excel, because this is all pure VBA. Nothing here today is access. So you should be able to implement this in any VBA solution anywhere. Once again, I do hope some of this is informative, and yeah, I guess we'll see you in the next video. Thank you very much for watching today, and please like, share, subscribe, and promote any of my content. It is greatly appreciated. Take care, everyone. Have a great weekend.